Hey everybody, I hope you're doing awesome. It's Brian Jenkins with Circuit Crush TV, and today I have another Arduino tutorial, and we're going to talk about using a servo motor with Arduino. And we can see we have this little servo motor here connected directly to the Arduino. Now, that may or may not be a good idea depending on the motor and what you plan on doing with it. So we're going to talk more about that in a minute. But I just want to demonstrate real quick what this does. So I'm going to plug in the Arduino and give it a second. And we see it spinning around, doing a 180, then reversing and doing another 180. Okay, so that is what this program does. And I'm not going to go into a lot of detail about how servo motors work or anything like that, but I do want to say a few things on motors in general. Now, motors can draw a fair amount of current, and the more load a motor has, the more current it's going to draw. And when a motor stalls, as in too much load, it can't handle it, it's trying, but just can't do it, that's when it's going to draw the most current. And we see this little thing here, this is the horn, it's called a horn, spinning around. And I took some current measurements earlier of this setup right here. And right now, no load, it draws anywhere from 60 to 185 milliamps, depending on where it is in the position or where it is in the program. Now, if I take this and grab it with my fingers and stop it and actually stall the motor, that shoots up to about 430 milliamps. Now, the Arduino Uno, the power supply regulator, is capable of about a maximum of 800 milliamps, no more. And when it's plugged into USB, of course, most USB ports are only good for 500. But you also have to factor in the chip is going to draw some current, the microcontroller that powers the Arduino, and, the little LEDs and stuff. So, you could get yourself in trouble real quick if, say, you have a couple of these hooked up directly to the board, and for some reason they stall. Say your robot runs into something or something like that. It could draw a lot of current, especially if it's a bigger motor like this here. This servo, we can see, is considerably larger than that one and is capable of drawing a lot more current than this little tiny one here. And actually, even this little one can draw more than 430 milliamps, and I'm going to show you right now how that is. I'm going to connect this. I'm going to disconnect that for a minute. And I'm going to connect this little servo motor here directly to my benchtop power supply. I've got these nifty little cables here. There we go. And let's do our 5 volts here and our ground here. And make sure they don't touch. We don't want them touching. And I'm going to plug the Arduino back in. Give it a second. Then I'm going to kick on the power supply. Now, we see this thing spinning round and round in circles this time. And let me show you what it's drawing no load. Anywhere from 110 to 140 milliamps, no load. And if I stop this thing with my fingers, it shoots up to about 640, between the high 500, 640 milliamps. So this could draw some significant amount of current, even a little motor like this. So just a word to the wise, a fair warning, when you're connecting things like this directly to your Arduino, be careful. Make sure you have a good understanding of the board's capabilities and how much power or current it's going to draw, rather. Now, let's jump on over and talk about some code.
Okay, guys, so here we are at the code, and this is actually just an example program that comes with the Arduino IDE. I didn't write this, full disclosure. This guy here did, and we could find it by going to File, Examples, and then down here to servo and sweep. So anyway, I just wanted to talk about this code real quick and go over some of it. Of course, we have to include the Servo Library, and that's what this line of code does. Next, we create a servo object. And this is a tutorial for beginners, so I'm not going to get into objects and classes, but just for now, know that you need to use this here to control a servo. And it says here 12 servo objects can be created on most boards. I believe with the Mega 2560 that number is higher. Anyway, we have the position. We want to start off at 0. And we have an integer here. And then we jump right into setup. And it's just one line of code. And all we're doing is attaching the object myServo, which we created here, to pin 9, which is one of the pins on the Arduino with pulse width modulation capabilities. And this dot attach here, you can find information about that in the Arduino reference. In fact, let's take a quick look at the Arduino reference, because it's a pretty good, indispensable tool. Okay, so here we are at the Arduino reference, and we're looking at the Servo Library. And this tells you a little bit about how servo motors work and all that. And here we have the functions used with the Servo Library, and we see right here the attach function. If we click on that, it'll give us some more information, and like I said, attach the servo variable to a pin. So I'm going to let you guys take a look at this on your own if you want to know more about the various functions within the Servo Library. Let's jump back over to the IDE. So here we are back at the IDE, and we jump into the main loop, and we see the good old familiar for loop. And we see we want to sweep from 0 to 180, so we start position with 0, and then we increment by 1 in steps of 1 degree. And this plus equals is a shorthand notation. It's the same thing as writing, and I talked about this in another tutorial, but plus equals is same as writing, and my typing skills just are not the best, so bear with me here. It would be the same thing as writing position equals position plus 1. Okay, so it's just a quicker shorthand way when coding to write stuff. And then here we write the position, we wait 15 milliseconds, and then here we jump into this for loop, which reverses it and spins it back the other way. Same basic concept, only here we're counting backwards instead of, and we see here it says minus equals instead of plus equals. You could do this kind of shorthand notation with, your addition, subtraction, multiplication operations. And that's really all there is to the code. Anyway, this was just an introduction to using servos with Arduino. There's a lot of other things you could do with servos and Arduino, of course, and we will talk about some of those later. Meanwhile, go out there and make something. If you're interested in Arduino and microcontrollers, you'll love how to get started with Arduino in 1 day or less. Get instant access now by clicking the link below in the description.